What's going on, guys? So in this video we're gonna extend this project and implement heap sort and quick sort into this sorting visualizer. We created this project from scratch in my last video, so if you haven't seen it, go check it out. But let's just jump right in. So first thing we got to do is add the buttons to select, heap sort, and quick sort. It's pretty simple. We did all the hard work in the last video, so now we just gotta really just copy these buttons and add the label heap sort to it. But if you notice on this on click to change the algorithm, if I pass in heap sort, obviously it doesn't work because it's not a supported type. So I'm gonna go here and add heap sort and quick sort to my algorithm type. So heap sort and quick sort. And so now I can do that, and I'm actually gonna copy this over and do the same thing. So this quick sort, just like that, and then here I wanted to say quick sort, and up here I need to change this to heap sort, so then it turns purple when the algorithm is selected. So see, now it works, and it calls the function onAlgo change, so we can change the algorithm. So we're good on that. Now let's actually get started implementing the algorithm and creating our heap data structure. So how I'm going to do this is I'm going to create a max heap, and when I call heap sort, it's going to put every maximum element or number at the end of the array continuously, and then we'll have an array that's sorted from ascending order, so from least to most in that order. So I'm going to go over here to algo context. And in this switch statement here, I'm going to do case heap sort. And for now, we just break from that, because I'm going to create a file here called heap-sort.ts. And then here I got to export a function. So I'll call it get heap sort anims. It takes in our array, which is an array of number. And we have that for now. So over here, I just want to call that function. So get heap sort anims, and we pass in our items, which is just really the array of numbers that we have. Okay. So I'm getting an error. So I just restarted the dev server and it seems to be working now. That was pretty weird, but we're just going to continue then. So we're calling this function now, and we're passing in our items. And let's just get started. So I'm actually going to create a class called maxHeap, and this will be our data structure. In this class, we'll have a field called size, and this is just the size of our heap. We're going to have our actual heap, and then we're going to have the constructor, which takes in an array, which is an array of numbers. And if there's no array, we just return. And so from here, we would do this dot heap is equal to array. And we have to be explicit for the type here. So we have to say it's an array of numbers. And so here, after this, we would heapify the array. So for that, we need to implement the sync operation. And I'm assuming you know how heaps work, but if you don't, it's basically just a tree. So it has a parent, has two children, and those two children have two children. And we can use an array to symbolize this tree. And basically in max heap, every parent is always bigger than both of its children. So a heap that's like this, that's not a heap. And we might get an array like this, so that's why we have to basically heapify it or make it a heap. So I'm going to implement the sync operation, which basically it's like, if there's something like this, it grabs the parent and it compares it to his children, and it switches its position with the larger child. And then it does that for whichever child was replaced. And it keeps going down the tree until we're done, basically. And we're going to do that for every element in the tree. This entire operation on the array will take O of n time, because the first level we don't have to do anything with because all these nodes don't have any children. So we can essentially skip that, and we're only going to do operations on half of the tree. On the first level of the tree, the operations will only be done once, because then the node will become a leaf and we'll stop at that. And then every time we go up a level, the nodes are divided by 2 and the work is incremented by 1. And if you divide the work done by all the nodes, it's like if we had done one operation on each node. And that's why it's linear time. So let's actually go ahead and implement it now. So we need to implement the sync operation, and it's going to take in an index in the array. And all it's going to do is while I times 2 is less than this dot size, and while this dot size is greater than 1, we do this operation. So our size, it's kind of like calling array.length. If our array has one item, it's going to be size of 1. And so in here, we want to declare a variable called j. And so we're doing I times 2 is less than size, because if I times 2 is equal to the size or greater, that means we're encountering a leaf node, and we can just stop this operation right there. So we want to actually get the child, the largest child of this ith node. So we can do let j equal to I times 2. But if I is 0, which is the root node, then j would also be 0, so we would do j equals 1. Then we do if j plus 1, and this is to select the bigger child because we're doing a max heap. So if j plus 1 is less than this dot size, and this dot heap at j is less than this dot heap at j plus 1, then we can go ahead and increment j so we can have the index of the larger child. But if this dot heap at I is already greater than the largest child, which is this dot heap at j, then we can break out and finish right there. Otherwise, we will exchange I and j, and then we'll do I equals j and continue. So let me implement the exchange helper function. Takes in 2 indexes, we'll call them a and b, and we'll do const temp equals this dot heap at b, then we do this dot heap at b is equal to this dot heap at a, then we do this dot heap at a is equal to temp. So we're basically just switching both values. So now we can actually call this dot exchange I and j, just like that. So now we have this sync operation, and now we can use this function to create our heap. So all we're doing is we're going to do for let I equals this dot size, and I forgot to set this dot size equals to array.length. So divide that by 2 and make sure that this is an integer, which is rounded. While I is greater than or equal to 0, I minus minus. So I'm basically doing what I explained earlier. I'm starting from the second level, and we're going to run this operation. So we're going to do sync I, and that's basically everything we got to do. And now let me go up here and do const priority queue pq is equal to max heap, and we pass in our items. And why is this getting an error? Oh, I forgot the new keyword. Okay, and so I'm going to do console log pq.heap. And we can basically tell if it worked. So I'm going to go here to my console and run it. Okay. That looks about right. So you can just tell by the glance if most of the elements at the beginning are larger than the ones going towards the end. It's a heap. But it's not sorted yet. This is just a max heap. It's not sorted. So now that we have a max heap, we can implement the heap-sort function. And what this function does is while this dot size is greater than 1, all we got to do is exchange minus minus this dot size and 0. So we're exchanging here's what we're doing. So we have a heap right now. Basically, I'm gonna draw it up here. So it's, you can imagine it's kind of something like this, right? And so we're exchanging the largest element, which is the root, with the last element. So going like that. And then when we decrement size, we're basically like, it's like if we were to just comment this out and ignore it, but it stays in our array. And then we're gonna run the sync operation on this top one. So then it would keep it as a heap. Then we repeat that same operation. Decrement size until size. And we're gonna keep on doing this. Let's say that this one is 2, this one is 3. Here, size will be equal to 3. We decrement it, so now it's 2. So this is 0, 1, 2. We have access to the second item in our array, and we switch it like that. Then over here, when we're doing our sync, we're making sure that we're only touching elements that are less than the size. So this will be ignored, and we'll keep it like this. Then size is equal to 2. We decrement it here, so size becomes 1, and we end up switching these two right here. And then when we run sync, which I'm gonna do now, when we run sync, we don't do anything because size is equal to 1. Because if we were to do something, it would actually try to make this a heap and switch it back, which is not correct. We want to keep it like this. So then the least element in the array is at the top, and then we're done with our sort. And we break out of this loop. So that's basically all we're doing. So we're doing this dot sync on 0. And that's it. That's heap sort. So here we do pq.heap-sort, and we would just want to return, and we can just return heap sorted pq.heap, and then we can do heap sorted array. And I'm going to implement this now. So we not only do I want to sort this, let's actually test this out. So I'm going to make sure that I did it right. I'm going to go here, run it, and check the console. So that looks sorted to me. Yeah, that looks sorted to me. So we want to return this over here and see how we're getting animations when we implemented insert and sort. We got the animation array, which is really just an array of indexes that were switched. They were just switched, and we just have the indexes. And then over here, in animate divs, which is in our animate file here, all we do is switch the array's height. So switch their height in the DOM and color them. And then is a nested set timeout. So we switch them, color them, and after the delay we take off the color, but we keep them switched, and that's how we like visualize it. So we want to do the same thing. We have an array of arrays, and each item in the array will be a tuple basically that contains the two indexes of the items that were compared and switched. And it's very simple to do. We can do this right here in our exchange. So here we can have anim array and make sure we explicitly declare the type of this. And here we can do at this dot anim array dot push a comma b. And then over here we just return pq dot anim array. Over here we're gonna extract that. So we destructure that. Here we get heap sorted and heap sorted anims. Oh, I named it heap sorted array. My bad. It's heap sorted anims. Okay. So now we have that, and all we have to do is run animate divs, which is that function I explained to you. And let me see what it takes. It takes in an object which has new array, and this would be heap sorted. It takes in the array, which is the animation, so heap sorted anims. And it takes in set items and settings. Okay, so now let's run heap sort. And it works, and that's very satisfying. It's very satisfying. So yeah, we got heap sort working. And it's so satisfying when it creates the heap. That looks so pretty. Okay, so yeah, that's heap sort for you. And I'm not sure what type of error I'm getting in here in this file. It's red for some reason. But now let's do quick sort. So I'm gonna go here and do case of quick sort and just call break. And I forgot the semicolon there. So I'm gonna create a new file. And it's going to be called quicksort.ts. So here I'm going to export the function const get quicksort anims. It's going to take in the array of numbers that we needed, and just that for now. And so we're going to have a partition function. And this is gonna call, well, first we cannot mutate our state, so we're gonna have to do const array is equal to, and we spread out the items array. And we do partition, and then here we're gonna pass in, and we're gonna have to make an animation array. So here we would do partition, pass in array, anim array, 0 for the low, and then array.length -1 for the high. And then here we would say array is a numbers array, anim array is a 2D array, then low is a number, and high is a number. And then I have to declare this type like that. So here we want to do if low is greater than or equal to high, we return, because there's no point in sorting in a subarray of size 1 because it's already sorted. Then here we want to set some variables. So less than is going to be equal to low, I is equal to low, our partitioning element is going to be equal to array at low. So this is going to be the first element in the array, which is already shuffled, so we don't have to shuffle it ourselves. And we're just going to have it called v for the partitioning element. And then greater than is equal to high. So then we do while less than is less than or equal to, while I is less than or equal to greater than, we run this function. So first we check if the array at I is less than. So here we're doing a 3-way quicksort, which has better performance in the case that there are duplicate elements. I know that in this project there is no duplicate elements, but I don't bother even remembering the normal quicksort because it's so inefficient when there's duplicate elements. So this is actually the one that I know, so I'm just going to implement that one. So first we check if array at I is less than our partitioning element. If it is, we want to exchange I++ and less than ++. So I need to actually create that function here, which is the helper function. Takes in A, which is a number, and B, which is also a number. And let's say it also takes in an array, which is an array of numbers, and our animation array, which is a 2D array. So here const temp equals array at A, array at A is equals array at B, array at B is equal to temp. So here we would actually call this function and pass in our array and our animation array. And then we do else if array at I is greater than our partitioning element. We want to exchange I with greater than minus minus, and we basically exchange it and then decrement our greater than. And then else if none of these things are true, we just increment I, which means that our partitioning element is equal to I. or array at I. Just to give you an example, I'm going to create this little dummy array. So something like this, right? So low and I are equal to 5 at the beginning. And we're just going to run through this code real quick. And we want to make sure we call partition on passing array, anim array, and then low would be low and high would be less than -1. And low would be greater than +1 and high would be high, just like that. So I'm going to comment this out and we're going to run through the code real quick. So the whole purpose of this is to get 5, or our partitioning element, to be in a place where every element before it is less than 5 and everything after is greater than 5. Then we do that same process on both halves of the array, and we do that until the whole array is sorted. So just to give you an example, here we have less than is equal to 0, I is equal to 0, V is equal to 5, and greater than is equal to 1. So here we compare, is array at I, which is 5, less than 5? Nope. This doesn't apply either, so now we increment I. So now I is pointing at 2. Now we compare, is 2 less than 5? It is. So now we switch them, and then I is incremented to 3. Now I is pointing at 3, and less than is pointing at 5. Then we do that again, and now I is pointing at 11, and less than is pointing at 5. Now we see that I is greater than 5. So what do? We switch I with greater than, and we decrement greater than. So greater than was pointing here, and now greater than is pointing at 2. Then we do it again. So now I is less than 5. 15 is greater than 5. So what we do is we do it again where we decrement greater than. So greater than is pointing at 2. We switch it with I, and then we decrement greater than. So now it's pointing at 10. Now I is still pointing at 2. Now 2 is less than 5. So we switch. Now I is pointing at 10. Less than is still pointing at 5. Less than stays pointing at 5. Now we compare I is greater than 5. So we switch. And basically for the end of the array, it's just going to keep switching I and greater than until both of them are on the same element. Once less than and greater than are on the same element, we escape this while loop and we call partition on these elements and these elements. And it does the same thing for them, and we have a sorted array. If we were to have any duplicate elements, in that case, when we compare them, I would just go up and here, and then we would just partition on these elements. That's why this is better for duplicate items in an array. Hopefully that makes sense. So now we have a sorted array. So let me just console log it and test it out like that. And I'm actually not calling the function. So first time we need to call get quicksort anims, pass in the items. So let's call it. And here we see a sorted array. So now we can go here and we just need to return an object that has our array, and we'll call it quick sorted, pass in the array, and quick sort anims, and pass in the anim array. And it's really easy for the anim array. All we need to do is go here, anim array dot push an array, a tuple with the index of A and B. Then here we would just extract that with a destructure. So here we get these things, and then we call animate divs, and we pass in an object, and that object has new array quick sorted. Then I think it's just R, and then quick sorted anims. Then it takes in set items and settings, and now it works. So that's it. That's basically everything for you. It works beautifully. We got heap sort working. Beautiful. And we have quick sort working. It's amazing. All right, so yeah, I know this was a long video. I hope you enjoyed it and learned from it, and I'll catch you in the next one. See ya.